Hey, Cam, this is solution stoichiometry. So I'll tell you that a majority of the stoichiometry we do this year will be with things in solution because most reactions are done in aqueous solution. So that means we're going to be using molarity. Okay, we'll be using molarity in there. So this is 16, question 16. Okay, letter A. So it's got a balanced equation. Okay, balanced equation. Yours might look a little different, but it is a balanced equation. The question, remember, stoichiometry, don't confuse stoichiometry with anything else, but all stoichiometry is how much of this are we using, how much of that are we using, how much AlCl3 is made, how much H2 is made, how much stuff is used in the reaction, how much stuff is made in the reaction. I can ask you that in grams. I can ask you that in moles. If we're doing concentration like molarity, I can ask you that in milliliters of solution that we would need. So this one's saying how many grams of aluminum, so we want to finish with grams of aluminum. Trying to get to grams of aluminum, so we want to get to, would you need to react with 35 milliliters of 2 molar HCl. So remember, in that many milliliters of that concentration, there's a certain number of moles of HCl. So we need to get that into moles, do our ratio, which is 6 to 2, and then turn it back into grams of aluminum. Okay? My one rule is I never start with molarity. Okay, so we're starting with HCl going to there. I always start with my milliliters. So, and put that into liters. So 35 milliliters is 0.035 liters. Just get used to being able to divide that by 1,000. Milliliters to liters and vice versa. So that is liters of HCl. To get from liters to moles, we use molarity. Molarity gets you from liters to moles and moles to liters. So remember, this 2 molar means 2 moles of HCl per 1 liter. It means that every liter of HCl contains 2 moles of HCl. That is your molarity. That gets you from liters to moles and vice versa. That label cancels with that. We're at moles of HCl. So we need to do a ratio from HCl to aluminum. 6 to 2 for every 6 moles of HCl, there are 2 moles of aluminum. Every 6 moles of HCl you use, we use 2 moles of aluminum. If it's asking for moles of aluminum, we'd be done. It wants grams of aluminum, so we just say that every 1 mole of aluminum weighs 27 grams. So if you're giving molarity and a volume, you can multiply those to get moles, do your mole ratio to get from one thing to the other, go from there. It's about 0.64 grams of aluminum. All right, I'm going to erase that. Next question. The equation here, I think, is balanced or not. Got a 2 in front of the last thing. Looks like it's balanced there. This one is saying how many liters of 0.75 molar CaNO3. So how many liters of 0.75 molar CaNO3? So we want to finish with liters of that. Is what we're trying to get to. And we know it's 0.75 molar, meaning 0.75 moles per liter. We'll be required to react with 148 grams of Na2CO3. So react with 148 grams of that. So we're going from here to here. Turn this into moles, our ratio. We do our ratio between those two things. And then we use molarity to get from moles to liters. So start with our 148 grams. We're going to go grams to moles of Na2CO3. So remember, you're looking up how much 1 mole is. So on the periodic table, add those up. 2 NAs, 1 C, and 3 O's is 106 grams. That cancels with that. To our ratio, which is 1 to 1 in this case. So for every 1 mole of Na2CO3, there's 1 mole of calcium nitrate. And that's a mole to mole ratio. So that mole and that mole cancels. Right now we're at moles. We want to finish with liters. And we know the concentration of this is 0.75 moles per liter. So we're going to put that in there. Remember, this means 0.75 moles per liter. That's the concentration of calcium nitrate. So the 0.75 will go on the bottom. There's 0.75 moles of calcium nitrate per 1 liter of solution. So that is your molarity in there. I put it in upside down because it's trying to go from moles to liters. So moles cancels, left liters on top. Multiply across top, up at the bottom, it's 1.86 liters. So remember, molarity gets you from moles to liters and vice versa. Okay, moles to liters, vice versa. All right, I will do one more question on this video. This one, how many milliliters of 0.1 molar PbNO3? So we have 0.1 molar, that's 0.1 mole of PbNO3 per liter of solution. Wants to know how many milliliters of that we would need to react with 75 milliliters of 0.2 molar. I'll tell you, you probably need to be able to do this question in your head at some point in time. Okay, we start doing some stuff multiple choice wise for AP tests. Probably need to be able to do that. Look at the ratio here. It's a 1-to-2 ratio. Okay, and these are in a 1-to-2 ratio in terms of molarity. So you can probably figure out how many milliliters you're going to need here. But let's say we don't know that. So we're starting with this, going to milliliters of that. Again, I don't ever want to start with my molarity. Start with my milliliters or my liters. So change 75 milliliters into liters. So 0.075 liters of NaI. My molarity gets from the liters to moles. So for every 1 liter, there's 0.2 moles of NaI. That's 0.2. Remember, that is your molarity right there. So molarity gets you from liters to moles. Do our ratio. Ratio is 2 NaIs, 2 moles of that to 1 mole of lead nitrate to 1 PbNO3. And then to get to milliliters, this molarity will get us from moles to milliliters. Every 0.1 mole of lead nitrate contains 1,000 milliliters, or every 1,000 milliliters contains 0.1 mole. So this is moles here, so we're going to say there's 0.1 moles of lead nitrate per liter or per 1,000 milliliters of solution. So your molarity, we used molarity there of NaI, use molarity there of PbNO3. Let's cancel with that. When you're done, your answer is going to be 75 milliliters. So it was the same number of milliliters because it was half as concentrated, and they're supposed to be in a 2-to-1 ratio. So we need 75 milliliters of that to react. Okay. Now there is another way to do that problem. Whenever we're going molarity and volume to molarity and volume, we can do this. Okay, we can do a little MV equals MV, just like we did for dilution problem. Because remember, molarity times volume is moles. Molarity times volume is moles. But we have to take into account the mole ratio, the 2-to-1 mole ratio. So if we're doing NaI over on this side, okay, so we have 75 milliliters of 0.2 molar. So 0.2 molar, 75 milliliters, equals, wants to know how many milliliters of this. So what volume of 0.1 molar. So this is MV for the lead nitrate, MV for the NaI. Here's the only issue. We have to take into account the fact that this has to be double that. So this is a little weird. You don't put the 2 on the side with the NaI. You put the 2 on the side with the other thing. Because to make these equal stoichiometrically, to make them equal, we have to double this. So you got to put a 2 over here. If this is like a 3 and a 4, you would cross them, put them on opposite sides. So I would take this times this, divided by these 2 multiplied together. So this times this divided by 0.2, and you still get 75 milliliters. All right, that's really quick. We do a lot of stoichiometry with this. Take care. Thank you.